Okay, so this should be the second video that you watch this year. So from me, the first one should be about why we have a flipped classroom. And if you watch that, you know what you're expected to do with this video. So if you haven't done that, go watch that first. Okay, so this video is about experimental design, which you've learned about experiments for many, many years. And this is, really nothing new. We're just further refining that content. So the first thing that I want to say is, before we jump into what that design is, that this is not the only way, the only way that science is done. Okay? Which sometimes is a little confusing because experimental design, a lot of teachers will say that it's the same as the scientific method. But I will argue against every teacher or anybody who says that because they are not the same thing. The experimental method is not the same as the scientific method. It only works, the experimental design only works if, and only if we can control all factors. So, for example, if we were trying to study the phases of the moon, we can't pause the moon to say, okay, we're going to change this one thing and see how it affects it. All we're doing is making observations and making inferences. And to me, that's what the scientific method really is. But you will see these two terms confused a lot. So let's talk about what this experimental design method really is. And so the first thing, and you've heard me reiterate this in class, it's all about asking questions, right? So asking questions from your observations, And that's really, I'd hate to put a number 1 here. I don't like to do that because it's not a linear process. It doesn't go step 1 to step 2 to step 3. It goes all around. So I'm going to not put number 1 there, but just put a bullet point. And so it's asking questions from your observations. That's the first thing that happens. And then the second thing that happens is that there has to be some kind of research. So you have to look into what are the normal or optimal conditions for whatever you're observing, whatever you're asking about. That's really key because based on that research, you can then make a hypothesis. Now, as you heard in class, or you may have heard this in classes before, you might have heard a hypothesis defined as an educated guess. And I will tell you, if you write that on a test or use that kind of language, you will get it wrong. That is not right. How can it be educated and be a guess? Guesses are kind of random, and so this is kind of an oxymoron. This is not a good statement. So what I like to describe a hypothesis as is a prediction. So you've learned the if-then sentences. If this, then something else is going to happen. Well, that's a prediction. That's what a hypothesis is. You don't always have to write hypotheses in the if-then format, but I think you've been trained to do that. They don't have to be written that way. And then the next step is to really think about how you're going to control variables to test, right? So control variables to test. So you want to test your idea. You want to see how well it's going to work, right? So there are two things that, all the things that could change have to be thought about. So there are two avenues to think about. So the thing that you want to change on your own is called the independent variable. And I want you to write down that this is the thing you change. I'm not going to write that down. I want you to write it down. So the independent variable, and the other things that could change, but you don't want them to change because you're only changing the independent variable, we want to keep them the same, so we call those things constants. Okay? Sometimes you might see this language, so sometimes they're called constants, and there's a fine distinction that we're not going to worry about in this video. I want you to ask me about it, so jot this down as a question. What's the difference between a constant and a controlled variable? Okay? So those are the two things that you have to think about, when you're thinking about an experiment. But when you think about the independent variable and the thing that you're changing in that, there are two other things to think about. So I'm going to do this in a slightly different color. So there are two groups. So we've got a control group control group and another group called the experimental group. Alright, so these two terms, I'm going to put quotation marks because these are full terms. The control group is, and I'm not going to cross this out, this is the normal group. So this is the group that you're going to compare your data to. If you didn't have a control group, you have no idea if your data means anything. So this is the normal group you're going to compare to. So it could be the normal amount of whatever independent variable you're going to change, or it could be no value for the independent variable, so you're not giving it any of that treatment. But the experimental group, and I'll write, actually, I should write an S there, experimental groups. It could be more than one group. These are all the other, these are the other groups that get the different amounts of IV, that get the different types of, or not types, maybe amounts is better, amounts of IV, or independent variable. That's the IV, okay? And so that's key to understand. And if you don't get that, make sure you ask me questions in class. But after you do all of that, there's one more thing that's changing that you have to collect. And this is the dependent variable. Dependent variable. And this really, I think of as the data that you're collecting. And the data could be quantitative, quantitative or qualitative. And these should not be new words for you, but if they are, let's talk about them. Quantitative. So we're looking at this word, think of quantity and quality for qualitative. So in quantitative, we're talking about numbers, some way of actually measuring, and in qualitative, we're talking about descriptions, like in color. Now, we could take a color and measure its wavelengths to have numbers, but we don't always have to do that. And so that's the key distinction. The one that you absolutely have to have for any kind of experiment, a real experiment, is something quantitative, because what you do with that, I'm going to scroll to the right here, what you do with those numbers next is some kind of analysis. And that's the next step in this process. Once you have that data, you have to analyze it and see, is there a statistical difference between my control group, I'm just going to abbreviate that as GP, my control group and experimental group or groups. Okay? And the answer could be yes or no. Either way, you're learning something new, and that's the point of science, right? And so you do that analysis, and then you come up with your conclusions, right? So you're writing what's the whole meaning of your experiment. And that is the experimental design. And I know that was quick. I hope that you got some bare bones information. I hope that you have some questions for me so that we can talk about them in class. But that is the experimental process. But I will say that sometimes these conclusions will lead back to another question, and you ask another question slightly differently. And that's really how science moves forward, where each answer comes up with lots of new questions that are going to be further investigated, either by yourself or some other scientist who reads your paper that you might write. Okay? But I think that's long enough, and I'll end there.